Okay. Okay. So for this, we need to get y on the right side.
You could, yeah. No, hold on. Okay, go on. If you did that, what would you do next? Sub it in
So
there.
for the top equation, you'd get 2kx equals 4 minus y plus y.
Uh, yeah, and then?
You sub it into 3y.
So the problem with that is it would eliminate y and would leave you with only k's and x's. We
Yeah.
want it the other way, where you eliminate k and x and keep only y.
So would you get 2kx on the right side of the equation for the top one?
You could. Let me see. You could bring y over and do it that way.
Okay. So it'd be 2kx equals 4 plus y.
Yeah, and then
You minus 4 on both sides.
that's the same thing.
Oh no, would you divide by 2 on both sides?
I would times by 2 on both sides.
Okay. So did you get 4kx
Yeah,
equals 8 plus 2y?
yeah. And then how could you use that?
You divide by 4 on both sides.
Um, you now have 4kx equals, and this one has 4kx.
Oh, so you substitute 4kx in, which is 8 plus 2y.
Yeah,
Equals minus 2. Oh no, plus 3y equals minus 2.
hold on.
Then you can minus 8 on both sides, which gives you minus 10.
Yeah,
And then you do 2y plus 3y, which equals 5y.
mm-hmm.
Then you divide by 5 on both sides, which gives you y equals minus 2.
That's great. And B.
So when it says a constant, does it mean it wants an equation?
It means, so k is just a number. So it's not like
Yeah.
a variable like x or y. We just don't know what number it is. Basically, if we want an expression for x, they want x equals, but instead of it being like y equals minus 2, it'll be x equals something to do with k. So we won't know what number it is, but k will be in the answer.
Okay. Should it be like x equals kx? No, no,
Um,
k.
Let me see. So you would make x the subject in one of the equations.
Yeah. So could you make the top equation x the subject?
Yeah.
So you would minus 2kx on both sides.
That would be if it was.
Or you could add y to both sides. Yeah.
Hold on.
And then
Hold on. Your first idea was good. That would be if this was plus 2k. This is x times 2k.
so you divide by 2 on both sides.
And I would, in one go, divide both sides by 2k.
Ah, okay. So would it be um x equals 4 plus y over 2k?
Yeah. So that's x in terms of k and y. We want x in terms of k only.
So you times by 2 on both sides.
Y is minus 2.
So it's 4 plus minus 2, or 4 minus 2, which is 2 over 2k, which is just k.
2 over 2k. It's not k. What is it? Two over 2 is the same as 1 over 1.
1k.
1 over k.
Oh, 1 over k.
1 over
Okay.
1k, yep.
Okay.
Great. So if you see, like, find an expression for x in terms of something, they could have said, like, in terms of pi. That means that will be in the answer. Yeah. Even if you're not sure how to do part A, you can use it to do part B. So they told you y is minus 2, and you use that. Normal simultaneous equations you're going to be fine for. It's this k type that is the one to practice. So that was linear. All right, how do we do quadratic?
Okay. So for this, would you want to make x the subject?
Okay, yeah.
The top one. So it becomes x equals 3 minus 2y.
Mm-hmm.
Then you substitute. Wait, can you substitute x into x squared? And then does that become a expanded bracket?
Yeah, what is the bracket?
3 minus 2y and then 3 minus 2y.
Great. And you would fully expand that bracket, fully solve it, and you'll get two answers, y equals something or y equals something. Would that be 7 marks?
No.
Go on.
But you need to work out what x is.
Well done. So I'm just gonna, I don't know the answer, but let's just say x equals 3 or y equals 3 or y equals minus 3. You would then sub those in there to get x equals.
Yeah.
Yeah, so simultaneous
Does it matter
equation.
which one you sub in, or do you need to do both?
Need to do both.
Okay.
Yeah, quadratic, so it's got 2 solutions. And in this case, like 2 pairs of solutions. Because it's now simultaneous. Okay, let me see this one. This seems very similar. Let's take a look. Show that is that. Hence on the pairs. I think you'll be fine.
Yeah.
For that one. See, it's the K type. That's the trickier one. Okay, there's just a little thing. We'll just go as far as the substitution bit. So how would you do part A?
So we need to make x a subject for this.
And then sub it in?
Yeah.
Let me think. I think if x is the subject, then you would get y squared, like all y's. They ask for x's.
So you'd make y the subject.
Yeah.
Which would give you 2 minus x equals y.
Yeah. And then sub that in. Go on, sub it in. What do you get?
X squared plus x brackets 2 minus x minus y squared equals minus 1.
What is y squared?
Oh yeah, 2 minus x.
Well done. And so just watch out for that. Now it has to be subbed in 2 different places. You'd fully expand, fully simplify, and you would end up with that. This is a 2-mark question, and so pro tip, I think you could just get away with writing x squared minus 6x plus 3 equals 0 after that, because this is worth 1 mark, and yeah. Hence or otherwise solve the simultaneous equations, and then once you get there, that's fine. Okay. Yep. All right, how do we do this?
So would we substitute into the 3 to the power of x? Would you substitute 3 to the power of 2y minus 2?
You can't use the answer that they give you.
Okay. So how would you do it?
Good question. 3 to the power of x, you have to make it as 3 to the power of something.
The half. Mine would just be a half.
3 to the power of what gives you 9?
A 3 to the power of 2.
Yep. And so that's it written a different way. How do you simplify?
You multiply them, so it gives you 2y minus 1.
Well done. 2y minus, not 1.
Oh, 2, sorry.
And so 3 to the power of something equals 3 to the power of something else. Therefore, what do you know about those two?
Therefore, 3x equals 9y minus 1.
No,
Oh,
no,
3x equals...
no.
x equals 2y minus 2.
Yeah, they're both to the power of the same thing. So let's see, x equals 2y minus 2. So this is kind of common question. You may not notice it, but you have to make them both to the lower base. And sometimes they'll have like 27 to the power something as well.
Yeah.
And you'll have to say, okay, 27 is 3 cubed to the power of z or something. And so that becomes 3 to the 3z. Part B, you're going to be fine for. I'm not worried about that. Let's see. So this is subbing it in 2 different places. That's going to be fine. Let me just do that. Okay, K-type. This looks good. Alright, yep. Very tricky. How about this?
Okay. So for this, would you substitute the bottom one into the top one by making x the subject?
Yeah. Yes, let me see. Find the value of k. Alright, so how do we go about that?
Do we make k the subject then, not x?
I think that would eliminate k.
Okay. I think we have to make x the subject, don't we?
So I see. So you'd make x the subject and then sub it in?
Yeah.
I see 3 x's, but only 1 y. What do you think's going to be easier?
Oh, 1 y, because there's only one.
And so, what would you do?
Plus a k over 2x on both sides.
Well done. Yeah, make y the subject. Go on.
Yeah. Which gives you y equals 1 plus k over 2x.
2x.
And you'd get kx squared minus x brackets 1 plus k over 2x close brackets, and then k plus 1 x equals the 1.
Yep. That's easy. Alright. What's next?
Would you multiply by the brackets?
Yeah. Just the
So
middle
you'd get,
one.
just the middle one. How come not the one on the right?
So, I might be giving the game away. Let's see. Let's just do the middle for now.
Okay. You get minus x minus k over 2x.
X times x.
R squared.
That's it. And now, how do we use this fact to find the value of k?
There's only two answers because it's a single point, one coordinate.
And so any idea how you can use that to find the value of k? Because you have a mixture of k and x.
Would you use the first equation and make it equal to x?
Discriminant. Let's see. And so the way I notice that is, like, if it's something x with that bracket, especially k, but if they intersect at a single point, then it's discriminant.
Yeah.
So basically what you need is something x squared plus something x plus something equals 0. And then
Yeah.
that will be your ABC, even if they, because k is just a constant. We just don't know what it is.
Okay. So it'd be kx squared.
Well, we have kx squared, but we also have minus k over 2x squared.
Okay. So it'd be k minus k over 2 and then x squared.
Yeah, and any idea, I mean, that'll work. Any idea what is k minus k over 2?
2.
What is 1 minus 1 over 2? And you can use calculator.
1 over 2.
Yeah, and so that will make it easier in a second. 1 over 2k, I'll leave it as k over 2 like they did. So it's k over 2 x squared.
Yep.
Now we want the x coefficient.
Will that just be minus x and then brackets k plus 1x?
Yeah, and you can incorporate that x in. If you're not sure, you can expand the bracket and then just refactorize with
Wouldn't
the minus.
the x's cancel out or not?
Well done. And so what are you left with?
K plus 1.
Doesn't work that way. Tell you what, minus x, expand the bracket.
Minus k plus x. Minus k minus x.
You're just expanding it by x, so it's going to be plus.
Okay.
Yeah, plus kx plus x, and now refactorize with x.
So that's been minus x plus kx. Oh, minus x. No. 1 minus 1 plus k.
Minus 1 plus k, and this one?
Which one?
The third one?
1 plus 1.
Yep. Notice anything?
Did the ones cancel out?
Yeah. And so you get?
And you get left with a kx.
Well done. Right, what is next?
Then do we need to make it equal to 1?
So that's equal to 1. So we want discriminant.
We don't know what c is though.
The discriminant works just like with factorizing, just like with solving quadratics, has to be equal to 0.
Oh, so the discriminant, so c is minus 1.
Well done. So that's going to be minus 1. Okay, do you remember discriminant?
I think so.
Alright, come
But as in like what discriminant?
find the discriminant for this in terms of k.
Oh, what you mean like a, b, c?
Yep.
So a is k over 2, b is k, and c is minus 1.
Quadratic formula. What is the bit in the square root?
The square root?
Yeah.
Oh, that's the... Oh, you mean... Oh, right, okay. B squared minus 4ac.
That's it. And so, what is that? We're trying to solve for k.
k minus 4 times k over 2 times minus 1.
And something's missing from the first one. B squared.
Is it squared? Oh, wait.
Yeah. Simplify.
And then would you multiply 4 by the bracket?
Yep.
Which would give you 4k. Wait, no. K over. Wait, would it be 4k over 2?
Yep.
And then you multiply by minus 1, which gives you just plus 4k over 2.
And what is 4k over 2?
2k.
Well done. They intersect at a single point. What does that tell you about discriminant?
But there's another set of like discriminants for the other point.
It tells you, 1 second. Whoops. Let's see. So this comes up a lot. X squared equals 9. What is x?
3.
Is there another solution?
Minus 3.
Yeah. X squared equals 0. What is x?
0.
Yeah, x is 0. So you could say x is plus 0 or x is minus 0, but that's just the same answer twice.
Yeah.
And so it's like one repeated root, it's called.
Okay.
How about the last one? X squared is minus 9.
That's not possible.
Yes. And so first one, how many solutions?
2.
Middle one?
1.
Last one?
0.
Yes. And so they call them real roots because you can have imaginary numbers. Let's see. So if you have the square root of a positive number in the quadratic formula, because you have the plus or minus, you're going to get 2 answers. If it is one solution only, like one repeated root, you know that it must come to 0. So b squared minus 4ac must be 0.
Yeah.
For that one. B squared minus 4ac, and that gives you 0. And so we're told this has intersected a single point. And so what is our discriminant equal to?
So is it just 1? So is it equal to 0?
Yeah. If there was 2 solutions, it'd be greater than 0. No solutions, less than 0.
Okay.
And then you solve for k.
So would you minus 2k on both sides?
You could calculator.
Oh, okay. I got it's minus 1 or 0, so minus 1.
I was expecting minus 2. Am I crazy?
Wait, oh no, yeah, wait. Yeah, minus 2.
Well done. Yeah, it says it's a non-zero constant. So k is minus 2. How would you use that to do part B?
Would you substitute that to the bottom equation?
You'd sub that into both equations.
Okay.
And then you would just solve them like normal simultaneous equations.
Yeah.
So it would be like minus 2x squared. This would be minus 1x because it's minus 2 plus 1, that type of thing. Minus 2 over 2 is minus 1. Alright, so big picture. They intersect at a single point. So what you want to do is just solve. You just want to solve these simultaneous equations, find out what is x, what is y. The problem is you've got 2 equations with 3 unknowns, the third one being k. You know they intersect only at a single point, and so you can use b squared minus 4ac equals 0.
Yeah.
If I gave you a normal quadratic, if I said an even more normal one, if I said this, there's no, Will I find any? Yeah. If I said this quadratic here, if I said find the discriminant, b squared minus 4ac, you're going to be fine. It's these k-type questions that are the tricky ones where you're working in reverse. Yeah, it intersects at a single point, or it intersects at 2 points, or it doesn't intersect. That's going to be discriminant. And watch out for that. Some k thing in front of x squared, and that's why I factorized it in front of, I put the x after it instead of the x before the bracket, just to show it.
Yeah.
And that's actually a giveaway as well. They'll do the same. They'll put x after it just to show that that's, A, B, C.
Yeah.
Okay, modeling. How do we do this?
So for this, do we need to make x the subject of the bottom equation?
You like working hard. What's an easier way?
Using h as the subject,
Yeah.
making them equal to each other.
Yeah, and you're right. It's already the subject, so that's nothing wrong with that. Because once you have x, it's easy to get y. Once you have y, it's easy to get x. In this case, they're calling it h. We have to do this all the way, unfortunately. Go on.
Okay. So could you add a fifth x to both sides?
Yeah.
Okay. Which will give you 27 over 10x.
That's great. And what else?
And then you minus 15 over 2x on both sides.
Yeah. And that's just 15 over 2.
Yeah. Which gives you minus 6.
That's great. Yep.
And then would you solve as a quadratic?
So solve that.
Okay. I got x can either be 5 or 4.
Yeah, so I was expecting something like that. Okay, and now we have to apply it to the real world. So determine whether the model predicts that the ball will hit the ceiling. So the flight of the ball is the x squared one. The ceiling is the x one. Will the ball hit the ceiling?
Would you sub it into x into the bottom equation? Well, both equations, x and 5. Well, 4 and 5.
You could, don't need to.
Would you just do it for both, for the bottom equation, the easier one? So for 4 and 5, you'd work them out.
You could, but you don't need to. So one answer will be 6.5. You'll get two different answers just like this.
Okay. So how do I know if it hits the ceiling or not?
That's the trick. Okay, so if this was pure maths, that would be a graph, and I know it will look like that. How far across are these two?
What, like that's in like 5 minus 4, which is 1.
Well, that's the distance, but yeah, that one's 4, that one's 5. And so does it hit the ceiling?
Yes.
Yes, and in fact, when it hits the ceiling the first time, then it'll probably just fall. What if you put this into your calculator and you got like imaginary stuff?
Then it has no roots, meaning that there isn't no place for like there's no roots for the curve, so it doesn't pass through a point.
And so would it hit the ceiling?
No.
No, exactly. So because we got two different solutions, so the curve does intersect with the line in 2 different points. If we got one solution, it would just touch it, and if you get no real roots, that means it doesn't hit the ceiling. It won't reach it.
Yeah.
Great. Okay, inequalities. I think you know what you're doing. Do you know how to do B?
Would you just sub into the calculator? Would that work?
You would, and so for 4 marks, what I would do is sub in x squared minus 5x minus 14 equals 0. And then I would do a little pretend. Let me do that one. So you sub it into the inequality one.
Okay. I got it's x is between. Oh no, it's just minus 2.7.
Go on. What exactly does it say?
X is lesser than minus 2.7, and minus 2.7 is lesser than x.
Is it like that with the comma?
Oh yeah, comma. Sorry, yeah.
Is it like that, or is it 7 is less than x?
Oh no, yeah, 7 is less than x.
Okay, yeah, it makes more sense to put the x on the left, and so you'd have to flip that. There you go. Let's see. I'm not entirely sure. You could always use your graphical calculator as well.
Yeah.
What shape will this graph have?
Would it be going for a U shape, right?
Yeah, that's going to be U shape because it's positive. And so we got 2 roots, and so if you wanted to, you could do that. Where is it greater than 0? It's greater than 0 like when x is greater than 7 or less than minus 2. A graph, a sketch would certainly show working out. Like anyone from a sketch could see it's going to be above the line outside, and it's going to be lower than the line. It's going to be less than 0 down there. Yeah, but definitely show working out by doing the equals one, and then I recommend calculator for the inequalities. Sketch doesn't hurt, just to be sure. I just don't know for certain what's necessary for the marks. What I don't want is if you put down the final answer but don't show any working, to end up with no marks, because I saw on a paper it said like no working, no marks. Okay, how would we do this? If you like, you can just describe it to me.
Okay. So for this, would you, for the right side, you'd multiply by everything in the bracket by 2, and then the left side, you expand the bracket by multiplying the 2 brackets together?
Yeah, and then?
And then you'd get it so you want all the x's on one side, right? And you want it to be 0 on one side.
Yeah. And how would you get all 6 marks for this one?
Could you do drawing of the graph? Yeah, the graph.
All right.
Okay.
Go on, just tell me. What would you do next?
You put it into the calculator and you get the roots, and then you'd mark the roots on the graph.
Let's see. Yeah, so the roots will be x equals 3 or x equals 4. Well, my graph isn't great. So 3 or 4.
Would it be on the right side? Yeah.
Yeah, and then? Because it isn't equal, it's an inequality.
Oh, you need to write it out as in like x is wait, 3 is greater than or equal to.
Right.
No, 3 is less than or equal to x.
Well, where is the graph less than 0? Just big picture.
Less than 0 on the left.
Where's the y coordinate less than 0?
Below the x-axis.
Yep.
Yeah.
And you could put this into your inequality solver at any time, and it will say x is between 3 and 4. But I think even without that red line, if you just have that sketch, you know, you could have just done that in your head and said, well, it's below the line between 3 and 4.
Yeah.
And you can just verify with the calculator for both of them. I'm just making sure you show working out. Yeah, so even though it's an inequality, do the equals. I recommend sketch and then calculator just to make sure you get the right answer. And no one will ever know. And worst case scenario, just put it in the graphical calculator, use that sketch, and then you just say, there you go, it's between 3 and 4. And you don't have to mess around it if you don't want to, but graphical calculator also does inequalities, and so you could even take it to that level. Let's see. Big picture. No, you're gonna be fine.
Yeah.
Yeah. All right. How about this?
So it's not equal to 0.
You can ignore that. That's just because you can't divide by 0. But they'll always write that down. Okay. So if you ever don't understand what that bit means, it x is an element of the real numbers or something. A lot of the time that's just you can't divide by 0 in this case, but kind of goes without saying.
Yeah.
You don't need to worry about it.
So for this, would you need to make it the inequality equal to 0?
Yep.
So would you minus 9 over x on both sides? So it gives you 8 over x squared minus 9x plus 1. Yeah. Well, 9 over x.
But what do you do next?
Would you need to... Could you solve that as it is in the calculator and draw out the graph, or would that not work as that is?
You could. I imagine you could do it graphically. Let's see. My concern is that for 5 marks might not be enough working out. But it's a very common type of thing. What's difficult about it is that it's fractions.
Yeah.
How would you get rid of the fractions?
Multiply by x and multiply by x squared on both sides.
Yep. And I would just go straight to x squared.
Okay. Wait, so what happens to the minus 9 over x then if it's x squared?
That'll be minus 9 over x squared over x.
Ah, okay. And would the 8 over x squared just become 8?
Well done.
Okay. So it'd be 8 minus... And then you could simplify the plus... Wait, would you multiply it? So it'd be 1x squared.
Yeah.
Or just x squared. And then it'd be minus 9x squared over x.
And simplify that?
Oh, it'd just be 9x.
Well done. Right side?
0.
Yep. And then?
And then could you simplify and you put that into the calculator?
Yeah, you would go through the
the
process, the whole making it equal thing, doing your little sketch, and then using the calculator for the inequality just to be safe. That's it. Let me see. A very common type of question. If you have the x's on the bottom, that's the difficult bit. So multiply everything by the denominator to solve it. And especially if it's x squared, I mean, you probably would have gotten there. All right, this is a good one. How about this?
So there's 2 roots to this answer.
Well done.
Okay. So for this, do you want to make kx squared the subject?
Nope. Real roots, you said the important bit. That means it's got two solutions. When do you see that? We saw something
In
to
a
do with...
quadratic?
Yeah, we saw something to do with that earlier. The number of solutions, the number of roots.
Oh, okay. So you have A, B, and C, the discriminants, which is K as A, B is 8, and C is 5. And you use B squared minus 4AC. So
Yeah.
it'd be 8 squared minus K. No, 8 squared minus 4 times A, which is K, times C, which is 5.
Yeah. So that's 64 minus 20k. What's next?
And then you'd make K the subject. So
Subject of
you'd
what?
add K
Has to
0 from equals.
So the trick, if there was one repeated root, it'd be equal to 0.
Oh, it's greater than or equal to.
Greater than 0.
Okay.
Just greater than.
Okay.
Yeah. If it was equal to, it'd be just 1.
Okay.
Yes, and so you solve that, and you get k. What is that? 64 over 20, and you. Let's see, and that's your answer. You'd simplify that. What would that be with k on the left side?
Would that be K is greater than or equal to? No, just K is greater than.
So what will happen to this?
Would it flip?
So that flips. That's less than.
Okay.
Yes. So just be aware of that. Let me just see. Yes. Real roots. If it's talking about the roots, what if it had said there's no real roots?
Then 0 is greater.
Yes. What would happen to this?
It would flip over all of them.
Yeah. So that would be less than 0. If it was one repeated root, it'd be equal to 0. Okay. All right. What's step 1 for this?
Okay.
And maybe 2 steps.
So we need to find the discriminant and then we substitute it into B squared minus 4AC.
Yeah. So what will that be?
That would be 4 squared minus.
Hold on.
4K squared.
Well done. 4k squared, and that's very common.
Minus 4 times A, which is 2, times C, which is minus 5K.
Yeah. And no real roots.
Which means it's less than 0.
Well done. And then it's just a normal inequality to be solved. What is this squared?
16K squared.
Well done. Yeah, well squared. Great. I'm happy. Yeah. Let me just check. Yeah. So k is just a constant, and so that's incorporated into it. No real roots less than 0. Yeah. Real roots, anything like that, discriminant. All right. So I was concerned that they weren't going to have too much about discriminant, but they do. Aha. Yes. Okay. Ignore everything. How would you do C? How would you do just C? Even if you didn't know how to do A or B.
Would you just write out as x squared plus 2x minus 15 is greater than 6 minus 2x?
Well done. And you would solve that. And so don't be put off by the other stuff. The answer to B is when these two are equal to each other.
Yeah.
And A, you have a graphical calculator?
Not on me right now.
Okay, but you have one?
Yeah, it's downstairs.
Okay, no, that's grand. You would just stick them in graphical calculator. I think that'll be fine. Yeah. Let's see. Yes. Okay, this is what it's all about. How would we do this one?
Okay. So for this, would you make x a subject of the bottom equation?
It's already has y as the subject, which seems much easier.
Oh, so you make them equal to each other, and then you'd solve it and add them and minus them on both sides to get just one equation that y is equal to,
Well done.
and then you'd solve it as a quadratic.
Yeah, and you get your two solutions, and is that 4 marks?
No, you want to work out what y is by subbing the x's into the equation.
Well done. It doesn't matter which equation, but just use the easier one.
Yeah.
Well done, grand. So they're talking about graphs and stuff, but it's the same process. Let's see. On a coordinate grid, shade the region that satisfies the inequalities. Let's see. So we'd have to sketch these two graphs. Let's see. So this one, y-intercept is minus 12. What are the roots? You could put it into the thing. All right. Hang on. Shade the region. So let's just say it looks like that.
Yeah.
And this is a negative one. Let's just say that one looks like that or something. And so I'll just kind of simplify this a bit. I'll say it like that. So we have to say where y is greater than the blue one and less than the red one. Aha. So how would you answer that in general? Let's just say that's just 2 and minus 2.
Wait, so we need to make one greater than the other or something?
I think so. Where is the y? Yeah, where is it?
Is that just the below the y-axis, like the area below the y-axis?
Let's
Well,
see.
between the 2 and the 2, the minus 2 and the 2.
Yeah, and it's the whole thing in between.
Yeah.
Them. That's it. Because it is greater than this one, greater than the blue one, and less than the red one.
Yeah.
That's what that's about. Oh man. All right. I think you know you well. It's kind of. This is kind of some GCSE stuff, but it's got 4
Okay.
now. Well. Hold on. Let's see. Yeah, so let's say that is y plus x equals 6. Let's say this one is y equals 2x plus 9. Then we want y is greater than 3. Sorry, I'll just do y equals 3. And then x, I'll use a red or something. And that one is x equals 0. Okay,
Yeah.
so how do we get the region that satisfies all 4 of these?
Okay. So is that just the triangle, like the smallest one in the middle?
Well, I don't know, but let's see. What I do is I delete the bit that isn't the one. So let's say x is greater than 0. So where would you delete?
You delete the whole, like, under the y-axis.
That would be y is greater than 0. This is x is greater than 0.
So is that like the whole left side of the screen?
Yeah. So we delete all that.
Yeah.
How about y is greater than 3?
So anything below y is greater than 3 gets deleted.
Well done. So all that gets deleted.
Yeah.
Alright. Y plus x is less than 6. And this is y plus x is equal to 6.
Wait, so what do... Oh. So is it... anything, like, going down, like going down to the bottom left of the thing.
So just think of it as above the line or below the line. We want to keep is less than 6. So where do we delete?
Oh, so it's anything above the line.
Yeah. And then how about that last one? Less than 2x plus 9.
Wait, so what would you delete there?
Well, we want to keep...
2x plus 9, so anything above it, right?
Well done. Yeah, anything above it. And what we end up with is this tiny shape in there.
Yeah.
So my one is kind of a quadrilateral, but it turns out it would have been a triangle.
Yeah.
I just sketched it. Yes, you can draw them with your graphical calculator as well, like y plus x equals 6, y equals 2x plus 9, y equals 3, x equals 0. And yeah, it's easiest to delete the bits that you don't need. All right, well, that was chapter 3, but there's lots of similarities with chapter 4, as you'll see. How do we do this?
Okay. So do you make y2 and then you minus 2 on both sides to get 0?
Yep, great. 2 equals 5 plus 2x minus x squared, and you solve it, and it gives you your
Yeah.
Your 2 x's. Sketch the graph. All right, you can always graphical calculator. Sketch that as well. State the number of...
So when I use graphical calculator, do I need to put f of x or just put in the quadratic x squared, x minus 1, x minus 3?
Just the long one. F of x is just short for that.
Okay.
They just gave it a name, so they don't have to type it out. So they don't have to type it twice. That's why. Let's see. How do you know how many solutions you'll get for let's say this one? Like when you have two graphs crossing over.
As in, like, what do you mean? Like two?
Like how do you know how many solutions you'll get? Like if they just ask you how many solutions will there be?
Well, 'cause it says x squared, meaning that there's going to be 2.
So sometimes there's no real roots. How would you know in this case?
Well, it's because y is equal to 2.
No, graphically. How many? Just by looking at the graphs, how many solutions you should get for the quadratic when you bring them together?
Technically, there's 4 roots, right?
How'd you get that?
Because there's on the one of the x-axis and there's one of the y equals 2 axis.
That would be if y is 0. So although it looks similar, I'm just talking about the curve and the line.
Okay. So you know there's 2 because of the graph. There's 2 roots.
Yeah. How do you know that?
Because it passes through the y equals 2 line.
Yeah. It's got 2 points of intersection.
Yeah.
So this one, it looks like a quartic x to the power of 4. So they want you to sketch that graph. Quartics tend to look like that. And let's say 2 minus x. Let's say that. So how many solutions will that have?
4.
Yeah, 4 solutions. And it's not necessarily. Sometimes you'll have like 2 solutions like that.
Yeah.
And so just be aware of that. That's 2 solutions. And you can see they didn't actually ask you to solve it. They just asked for how many solutions. Let's see. What will happen to the f of x if they do y equals f of x plus 2? What will change there?
As in, what would you mean, like the y equals f of x plus 2?
So you may not remember, or I don't know. y equals the f of x becomes y equals the f of x plus 2, what will happen to the graph, or how will the graph of y equals the f of x plus 2 be different from y equals the f of x?
Would it make it so the y line is higher?
Yeah, by how many?
2 more, so it'd be like 4.
Yeah, in general, it's going to move it 2 up. So
Yeah.
it's like you're adding 2 to all the y's. Y is the f of x. If you do the f of x plus 2, you're adding 2 to all the y coordinates. So this blue graph is going to shift 2 higher.
Yeah.
But maybe that's okay. So that's all the stuff for the next one. So the next one. So transformations of functions is difficult, but let me just see. 1, 2, 3, 4, 5, 6, 7. So there's 7 questions for the next one, but we got through like 20 for this one. All right, let's see. This one. What is it talking about? Find an expression for x in terms of k.
So it'd be x equals.
Yeah. And what is it? What do you know about it if it says in terms of k?
It means that they want x equals k, and then the equation.
Yeah, it means k will be in the answer. So so if they say like solve for y equals -2. If they say solve for x in terms of k, that means it'll be x equals as well, but k will be in the answer, so you won't know what the number is. Okay, I think you're fine for their substitution.
Yeah.
Substitution. How do we do these ones in general? Something to the power something equals.
You need to figure out what what the number on the left is used to square to find the number on the right, and then you use that to times it by the x.
What if it had been, let's say, 81 to the y minus 1?
But as in like what's... Oh, as in like... Okay. So would it just be 3 to the 4? Wait, no.
Correct. Yeah.
Yeah, 3 to the 4.
And you would go from there. And you would just have to figure out 3 to the power of what? It might be, 343 because it's 7 to the power of something like that. So discriminant comes up a lot. B squared minus 4ac, it comes from the quadratic formula, and you can't square root a negative. The square root of 0 will only have one answer, and the other, if it's bigger than 0, then it's going to have 2 answers. That's where discriminant comes from. If they ask you to find the discriminant of something easy like this, you're going to be fine. It's very common that they ask you to do it in terms of k, and it looks a bit weird like that. K plus 1 is b, because that's the number in front of x. K is just a number. They say k is a constant, and so b is k plus 1.
Yeah.
Looks weird, but it's very common that that will come up. Modeling, yep, applying it to the real world just isn't easy in general. But in general, there was 2 points of intersection, and so yeah, it'll hit the ceiling. If there was no real roots, it wouldn't, type of thing.
Yeah.
These inequalities, I think you're all right. Make sure to do the equals as well to show working out. If you just got it in one go, I'm not sure you'd get the marks. How do we deal with these fraction ones?
Multiply by x squared, or whatever the highest x is, as in like if it was x cubed, you'd use x cubed instead.
Yeah. Why was this greater than 0?
Because it had real roots.
And why was this one less than 0?
Because it had no roots.
Yep. Great. That one's fine. If you're ever not sure about part A or B, usually you can do part C without it. You can do part B without part A. They design it that way, so you're not stuck. Yeah, these ones, they look weird, but where is it greater than that and less than that in between?
Yeah.
that's how that works. Delete the bit you don't need, I find, is the easiest way to do those. And yeah, great. How was that for you, Adam?
That was great.
And so next chapter next time?
Yeah.
Great. Any questions for me in general?
No.
All right. Well, well done, Adam. You did great. And I look
Thank
forward
you.
to talking again next time.
You too. Bye.
Take care. Bye bye.